Lesson 12.3, Determinants and Cramer's Rule. Well, we've been studying all these matrices and must have some uses, and we're going to look at those today. We'll look at how to solve systems of equations using Cramer's Rule. We'll find the area of a triangle when we know only the coordinates of the vertices. And there's some other uses. We just aren't going to go into them today. A determinant is a number associated with a square matrix. It is not unique. Different matrices may have the same determinant, but it's useful. Symbolized by the det, A, or what looks like absolute value of A, but these vertical lines around a matrix means determinant. Vertical lines mean determinant. I'm not going to answer a question on the test about what do these vertical lines mean. You need to know. So how do we find the determinant of a 2 by 2 matrix? We multiply along the down diagonal and subtract the product of the up diagonal. So it's down minus up. So for this one, it's down, just 2 times 4, minus the up, 3 times negative 1. So it'll be 8 minus negative 3, which is 11. All right, so how about a 3 by 3 matrix? Well, it's still going to be down minus up, only what we're going to do is we're going to copy the first 2 columns behind the matrix, and then it's 3 downs minus 3 ups. For example, here's this matrix. I'm going to take these first 2 columns and copy them over. And now we have downs. So I have 1 times 5 times 9. Another down, 2 times 6 times 7. And then a third down, 3 times 4 times 8. Minus the ups, 7 times 5 times 3, minus 8 times 6 times 1, minus 9 times 4 times 2. So the downs we added, the ups we subtracted. And people ask, well, why didn't this 4 get used? But it did right there, and this 5 got used right there. Each number got used twice. All right, so let's just simplify. So that's 45. 2 times 6 times 7 is 84. 3 times 4 times 8 is 96. 7 times 5 times 3 is 105. 8 times 6 times 1 is 48. And 9 times 4 times 2 is 72. Add those all together, and you get 0. What? All it worked for 0? Yeah, 0 is just a fine number. So one use of determinants in matrices is to find the area of a triangle. The area is 1/2 of x1, y1, 1, x2, y2, 1, x3, y3, 1, where the x's and y's are coordinates of the vertices. So in geometry, when you had these points, what we had to do is find the length using the distance formula, and then we had to find the slope and do a perpendicular slope until they met, and then find the point where they meet, which might require finding an equation of the lines and doing the system of equations, and then we can do the distance there, and then it's 1/2 base times height. Wow, this is so much easier. Just plug in the 3 coordinates of the vertices, find the determinant, and it's 1/2 of that. This plus and minus simply means to make the area positive. Just use the plus or the minus, whatever is needed to make your area positive. All right, find the area of a triangle with these vertices. All right. we're going to plug it into our formula. Area is plus or minus 1/2, and then these are the points right there. And it really doesn't matter which order you put the points in. Copy the first two columns so we can find our determinant. Down diagonal, 2 times 1 times 1 is 2, plus down diagonal, 4 times 1 times 2 is 8, plus down diagonal, 1 times 5 times -2 is -10, minus the up diagonal, 2 times 1 times 1, minus the up diagonal, -2 times 1 times 2 is -4, minus the up diagonal, 1 times 5 times 4 is 20. And all of that is plus and minus 1/2 times that. So we add together all the things, and we get 2 and 8 is 10, and a -10 is 0, -2, and then plus 4 is 2, minus 20 is -18. Half of 18 is 9, and we want it to be positive. So the area of the triangle with those vertices is 9. Our other application is how to solve a system of equations using matrices. So one way to do that is with Cramer's rule. So what we do is we write our equations in standard form, so it's like your system with the x's, the y's, and the equal signs all lined up. And we make a matrix out of the coefficients. And then we write some fractions. For a 2 by 2 system, if it's ax plus by equals e and cx plus dy equals f, we get this. X is that determinant over the other determinant, and y is that. What's really cool about Cramer's rule is you can solve for x or y without finding the other. All right. The bottom is all the coefficients. The top is the same as the bottom, only the column you are solving for is replaced by the constants. So the top is the same as the bottom, just the column you are solving for, like when you're looking for x, the first column, you're looking for y, the second column, is replaced by the constants. These are the constants. So let's use Cramer's rule to solve this little system. All right, so x is, the bottom is all the coefficients, 2, 1, 3, and -2. The top is the same as the bottom, except for the x column is replaced with the constants. Those are the constants. Otherwise, it's the same as the bottom. Find your determinants. That's -2 minus -23. On the bottom, it's -4 minus 3. So it looks like it's 21 over -7 or -3. So x is -3. For the y, the bottom stays the same. The top is the same as the bottom, except for the y column is replaced with the constants. But everything else is the same as the bottom. Find your determinants. So that's -46 minus 3. And the bottom, there's no need to calculate it again because it's the same as the x. The bottom was negative 7. We found it before. So I have negative 49 over negative 7, which is 7. So our answer is negative 3, 7. See, pretty quick and easy. So how would you use Cramer's rule to solve a 3 by 3 system? Well, it's the same as the 2 by 2 system. The denominator is the determinant of the coefficient matrix, and the numerator is the same, only with the column of the variable you're solving for replaced with the equal column, or with the constants. All right, let's use Cramer's rule to solve this system. Well, let's start with x. The bottom is just the coefficients. 2, negative 1, 6, 6, 4, negative 5, negative 4, negative 2, 5. The top is the same as the bottom, except the x column is the constants. Again, that's the constants. Everything else is the coefficients, the same as the bottom. Now we need to find these two determinants. Copy over the first two columns. And then multiply. So that's negative 4 times 5, which is negative 80, I think, plus negative 1 times negative 5 times 9, which should be 45, plus 6 times negative 7 times negative 2, which is 84, minus, let's go up, 9 times 4 times 6, 216, minus negative 2 times negative 5 times negative 4 is negative 40, minus 5 times negative 7 times negative 1, which is 35. On the bottom, we'll have 2 times 4 times 5, which is 40, plus negative 1 times negative 5 times negative 4 is negative 20, plus 6 times 6 times negative 2, which would be negative 72, minus, let's go up, negative 4 times 6 is negative 96, minus negative 2 times negative 5 times 2, which is 20, minus 5 times 6 times negative 1, which is negative 30. All right, on the top, if I add those together, I get negative 162 on the bottom. I get 54, and when I divide those, I get negative 3. So x is negative 3. For the y, the bottom stays the same. So I know my bottom is 54. There's no need of recalculating it. On the top, the y column is the constants. The other two columns are just the coefficients. So the x's is just the coefficients of the x's, same as it was below. And the z column is just the coefficients of the z's, same as below. Copy over the first two columns and find the determinant. We'll have 2 times -7 times 5 plus -4 times -5 times -4 plus 6 times 6 times 9, which is 324, minus, now going up, -4 times -7 times 6, which is 168, minus 9 times -5 times 2, which is -90, minus 5 times 6 times -4, which is -120. And the bottom is the same as it was for the x, which is 54. So on the top, we have -70 plus -80 plus 324 minus 168 minus a -90 minus -120, which gets me 216 over 54, which is 4 when I divide. Well, we still have the z. Again, the bottom of the z is 54. The top, the z column, is now the constants, and the other two columns are just the coefficients. Copy over the first two columns and find the determinant. 2 times 4 times 9 is 72. -1 times -7 times -4 is -28. And then -4 times 6 times -2 is 48. Minus going up, -4 times 4 times -4, minus going up again, -2 times -7 times 2, 28, minus 9 times 6 times -1, which is -54. The bottom stayed the same, was 54. If I add these all together, I have 54 over 54, which is 1. So my answer is -3, 4, 1.